Hello, my name is Daniel, and today we will be going through the AMC 12A from the year 2002. So let's get started. First problem, compute the sum of all the roots of this. Okay, so we see 2x plus 3 and 2x plus 3, they're common, so if we take those out, it's 2x plus 3 times 2x minus 10, right? So this gives us x equals negative 3 over 2, and x equals 5, right? But then 5 is equal to 10 over 2, and since we have to add these together, we get 7 over 2, right? So 7 over 2 is the answer, it's A. Number 2, Cindy was asked by her teacher to subtract 3 from a certain number and then divide the result by 9. Instead, she subtracted 9 and then divided the result by 3, giving an answer of 43. What would her answer have been had she wrote the problem correctly? Okay, so let's say that the certain number was A, right? So what she should have done was A minus 3 divided by 9, right? But then what she actually did was A minus 9 over 3, and she got 43, right? So this is 43. So what A is A equals 43 times 3 plus 9, and since 9 is 3 times 3, this is 46, this is 3 times 3, so that is 46 times 3, right? And so if we put 46 times 3 into right here, then this gives us all over 9, and then 46 times 3 minus 3, this is 1 times 3, so this is 45 times 3 over 9. This equals 5 times 3, which is 15. So the answer is 15. It's A. Number 3, according to the standard convention for exponentiation, 2 squared equals this much, right? If the order in which the exponentiations are performed is changed, how many other values are possible? Okay, so first of all, what we have to see is that 2 to the 2 squared always equals 16, right? No matter how you look at it, right? Because 4 squared equals 2 to the 4th power, which is all 16. And so 3 times together, that's just all the same thing, right? And so the only values that this is going to give us is either 2 to the 16th power or 16 to the or 16 squared, right? But then it asked us how many other values are possible, and this one, 2 to the 16th power, is there already, so this can't be it. So we have only one other value. The answer is B. Number 4, find the degree measure of an angle whose complement is 25% of its supplement. Okay, so first of all, complement, this is 90 minus that degree, and supplement is 180 minus that degree, right? So 90 minus x, let's see, the angle is x. This would equal 1 over 4 times 180 minus x. So 4 times 90 minus x, so that's 360 minus 4x. This equals 180 minus x. So 180 equals 3x, and x is equal to 60 degrees. So the answer is 60, it's B. Number 5, each of the small circles in this figure has radius 1. The innermost circle is tangent to the 6 circles that surround it, and each of those circles is tangent to the large circle and to its small circle neighbors. Find the area of the shaded region. Okay, so the shaded region is the, so that's the whole circle, minus 7 of these small circles with radius 1, right? And so if we find the large circle first, then the radius of the large circle would be 3, right? Because each of the small circles has radius 1, so this much would be 1, 1, 1, that making the radius of the big one 3. So the big circle, this would be 3 squared pi, this is 9 pi. And the small circles, those would be 1 squared pi because the radius is 1. And so this would be pi. But then we have 7 of these, right? So what we have to do is the big thing, which is 9 pi, and then we have to minus 7 times the small ones, pi. So this is just 2 pi. So that's just 2 pi. So the answer is 2 pi, which is C. Number 6, for how many positive integers m does there exist at least one positive integer such that m times n is less than or equal to m plus n? Okay, so there's two ways of looking at this problem, and one is, like, you could just see it right away. Like, if n equals 1, then that means just m is less than or equal to m plus 1, and that's always going to be true, right? For like whatever m is, that's always going to be true. And so you could get the answer E right away, or if you don't see that, or you could say just you could give this to the you could make that go to the other side, and so have mn minus m minus n is less than or equal to 0. So m minus 1 times n minus 1 is less than or equal to 1. And here, if n is 1, then whatever m is, it's always it's always satisfying less than or equal to 1. So m can be anything. And so here from there you could get answer E. Whatever way you choose, the answer is E. Number 7, a 45-degree arc of circle A is equal in length to a 30-degree arc of circle B. What is the ratio of circle A's area and circle B's area? Okay, so let's say the radius of A is just small a, and the radius of circle B is small b. Alright, and so since this is 45-degree arc, that's 2 pi a times 45 degrees, so that's 1 over 8. And this equals 30 degrees, so that's 1 over 12. It's 2 pi b times 1 over 12. And so if we cross multiply, then we get 12a equals 8b, and so this gives us the ratio of a to b. This would equal 2 to 3, right? And this is the ratio of the radius, so this is just the length, right? But then we want the ratio of the areas, right? And so to get the area, what we have to do is we have to square this and square this, and so that would be 4 to 9. So the area's ratio is 4 to 9, which is 4 over 9, and this is equal to a. Number 8. Betsy designed a flag using blue triangles and small white squares on a red center square, as shown. Let B be the total area of the blue triangles, W the total area of the white squares, and R the area of the red square. Which of the following is correct? Okay, so first of all, what we want to do is we want to divide this into same like 14 like grids, right? And so if we do that, then we will get something that looks like this. And this, and our last line is this one, right? And then for each square, right? For each square, notice that the area of the blue, so the area of the blue, no, I'll do this in orange. So the blue area, this is equal to the white area, right? Same for here. The blue area is equal to the white area, right? And so for these things, the blue area is equal to the white area, and that's for this, like that. And so for this, the blue equals the white, right? And if you see, that's all of the blues and whites that exist, right? So all of the blues are equal to all of the whites. The answer is A. Number 9. Jamal wants to save 30 files onto disks, each with 1.44 megabyte space. 3 of the files take up 0.8 megabytes, 12 of the files take up 0.7, and the rest take up 0.4. It is not possible to split a file onto 2 different disks. What is the smallest number of disks needed to store all 30 files? Okay, so the problem gave us that this has 1.44 megabyte space, but then this last hundredth digit, this is like totally not necessary because all of our file spaces, they are up to one decimal place, right? So this just last 4, that's just not needed, right? So each disk has 1.4 space, and we have 0.8, we have 3 of these. Yeah, so we have 0.8, we have 3 of these, and 0.7, we have 12 of these, right? And we have 30 in total, so 0.4, we have 15 of these, right? And since 1.4 is exactly 2 times 0.7, then that means we will have 6 disks of 0.7 times 2, right? And for 0.8, these we will have like 0.8 and 0.4 together. That's the only way this is possible, and so this will be 3 disks, right? Three disks, and so if we take away 3 disks from 15, then that will mean that 12 are left over. 12 are left over, right? So we have 4 times 3 is 12. So we have 4 disks with 3 files each. So 0.4 times 3 each, and so that would make 12 files, right? So in total we have 3 and 6 and 4 disks, and so they go up total to 13 disks, and 13 disks is the answer. It's B. Number 10. Sarah places 4 ounces of coffee into an 8-ounce cup and 4 ounces of cream into a second cup of the same size. She then pours half the coffee from the first cup into the second, and after stirring thoroughly, pours half the liquid in the second cup back to the first. What fraction of the liquid in the first cup is now cream? Okay, so let's just visualize this in a diagram. And so if we just move these around, then we will have our answer. It says she pours half the coffee from the first cup to the second. So she pours half the coffee from the first cup to the second. So half the coffee from the first cup to the second. And then and then she pours half the liquid in the second cup back into the first. So she pours half the second cup into the first, right? So this is what happens. And if we just put these down, this will be our final our final result, right? And it asked what fraction of the liquid in the first cup is now cream. So out of 5, 2 are cream. So this is just 2 over 5. The answer is D. Problem number 11. Mr. Early Bird gets up every day at 8 a.m. to go to work. Not very early. If he drives at an average speed of 40 miles per hour, he will be late by 3 minutes. If he drives at an average speed of 60 miles per hour, he will be early by 3 minutes. How many miles per hour does Mr. Bird need to drive to get to work exactly on time? Okay, so let's say that Mr. Bird he should drive so he needs X minutes to go to work on time, right? And so then our equations will be 40 times x plus 3 minutes. This is equal to 60 miles per hour and x minus 3 minutes, right? Because this is getting there late and this is getting there early, right? And so if we expand 40x plus 120 equals 60x minus 180, and so that gives us that 300 equals 20x, yeah. And so x equals 15, so he needs to get there in 15 minutes, right? And so 60 times x minus 3, so 60 times x minus 3, this equals the speed that he needs to drive times x, right? But then since x is 15, then we get 60 times x minus 3, this is equal to 60 times 12, and this is something times 15, right? And 60 times 12, this is equal to 15 times 4 times 12, because 60 is 15 times 4, and so this is 15 times 4 times 12, which is 48, right? So this is 15 times 48. 48 is the number that we were looking for. It's B. Number 12, both roots of the quadratic equation, this one, are prime numbers. The number of possible values of k is. Okay, so since we are looking at the roots of that quadratic, right? So the sum of the roots, they are 63, right? But then this is an odd number, right? This is an odd number. And so for the sum of the roots to be 63, then the roots have to be, one should be odd and one should be even, right? One should be even. But then they are both prime numbers, right? And so the only even, so the only even prime number, this is 2. And so one root must be 2, and since the sum of the roots is 63, the other roots must be 61, right? And so there is only one possible value of k, because k is the multiple of the roots. So 61 times 2, this is 122. So that's the only possible value for k. The answer is B. Number 13, two different positive numbers, a and b, each differ from their reciprocals by 1. What is a plus b? Okay, so let's have something that refers to both a and b. Let's call them x collectively, right? So x minus 1 over x, this could be 1 or minus 1, right? So they can be plus or minus 1 because it just said that they differ from their reciprocals by 1. So just the gap is 1, and we don't know the sign, right? So x minus 1 over x is plus or minus 1, and if we multiply x to both sides, we get x squared minus 1 equals plus or minus x, and so we get x squared plus or minus x minus 1 equals 0, right? And if we use the quadratic formula on this, then we get x equals all over 2, and then plus or minus 1 plus or minus root 1 plus 4, and then this is root 5, right? And they have to be positive numbers, and so this number, and so this sign, it just cannot be negative, right? Because if it's negative, then all the x values are going to be negative, so this has to be positive. And so this gives us the two values of a and b. So that gives us a and b. A and b, they are root 5 minus 1 over 2 and root 5 plus 1 over 2, right? And so if we add these together, this becomes root 5 times 2 divided by 2, so this is just root 5. The answer is root 5, it's C. Number 14, for all positive integers n, let fn equal log 2002 n squared. And we just see that this is equal to 2 log 2002 n. And let n equal f11 plus f13 plus f14, which of the following relations is true? Okay, so since we have 11, 13, and 14 in there, then we can just plug them into here, and so we get 2 log 2002 of 11 plus 2 log 2002 of 13 plus 2 log 2002 of 14, right? And then if we get all the 2's together, we get 2 times log 2002 of 11 this, so we get this value plus this value plus this value, right? And that just becomes log 2002 of 11 times 13 times 14, right? So this is 2 times log 2002 and then if we calculate this thing, that becomes actually 2002, right? That is 2002. So this is just 1, so that's away, so we have 2 left. So the answer is 2. It's D, n equals 2. Number 15, the mean, median, unique mode, and range of a collection of eight integers are all equal to 8. The largest integer that can be an element of this collection is... Okay, so we have 8 integers, 5, 6, 7, 8, and then the mean, median, and range are... The mean, median, mode, and range are all equal to 8. So since the median is 8, and the mode is 8, so we must have at least two values of 8. So we have 8 in here, and then for us to make sure that it really is the mode, then we will have 8 there, and then the range is also 8, right? And so if we have numbers like a here, then we would have a plus 8 here, but then for a and a plus 8 to be the maximum possible, we will have a like that too, right? But then the mean is all equal to 8, so the total sum is 64, right? Which is 8 times 8, but then since we have 5 8's already, that means we just have 3 8's left, so 3 times 8 is 24, so 24 equals these 4 a's. 24 equals 4a, so a equals 6, right? And so that gives us, this is 6, 6, 6, and then this a plus 8, that would equal 6 plus 8, which is 14, right? And we wanted the largest integer, so that's 14, it's D. Number 16, Tina randomly selects 2 distinct numbers from the set 1, 2, 3, 4, 5, and Sergio randomly selects a number from the set 1 to 10. What is the probability that Sergio's number is larger than the sum of the 2 numbers chosen by Tina? Okay, so let's first see what can the sum of the numbers chosen by Tina be. So Tina's sum, they can be either 3 for 1 and 2, or we have 4 for 1 and 3, we have 5 for 1 and 4 and 2 and 3, so let's just write that twice. And 6 also, 2 times 2, 4, and 1, 5, so we have 2 6's. And we also have 7, and we also have 2 7's, 3 4, and 2 5, like that, so that gives us 7 7. And for 8, we have 3 5, so we have 1 8, and we have 1 9, like that, right? And for from this, Sergio's number, since he has 10 choices to choose from, his number just has to be greater than these numbers, right? And so for his number to be greater than 3, he just needs 7 out of 10. This is 6 out of 10. This is 5 out of 10. And we have one more, so we have one more 5 out of 10. And same thing for here, 4 out of 10. One more 4 out of 10. It's 3 out of 10. One more 3 out of 10. 2 out of 10. And one more, and just that. So we have 2 out of 10. And lastly, we have 1 out of 10. And this value should be like 10, right? That's the only possible way that Sergio's number should be larger than 9. And so what we can do is we have to just add all of these things together. So this whole thing becomes it's all over 10 times 10, right? Because we have 10 values of 10 in the denominator, and they are all like added to, and they're all added together. And then we have 1 plus 2 plus 3 plus 4 plus all to 7 plus 3 plus 4 plus 5 left over. So we have 1 plus 2 plus all the way to plus 7 plus 3 plus 4 plus 5. So this is all over 100, and this much is 7 times 8 over 2, so that's 28. And then 3 plus 4 plus 5, that is 12, so 20 plus 12. So this is 40. Yeah, so this is 40 over 100, which is equal to 2 over 5. So the answer is 2 over 5, it's A. Number 17. Several sets of prime numbers, such as this one, use each of the 9 non-zero digits exactly once. What is the smallest possible sum that such a set of primes could have? Okay, so we have to use each of the 9 non-zero digits exactly once. So we have to use 1, 2, 3, 4, 5, 6, 7, 8, or 9. They have to be used exactly once, and they should be all primes, right? But then if you see the number 4, 6, and 8, they cannot be in the units digit of a prime number, and so they must be in the tens digit, right? So our minimum sum would be something that has 4, 6, and 8 in those are in the tens digit, so we have 40, 60, and 80, and all the others are the units digit, so 1, 2, 3, 5, 7, 9, right? And so if we take the sum of these numbers, then these would have a sum of, this gets 180, this gets 190, we have 200, and so we have 207, right? So we have 207 as the as the sum, and yes, that is indeed an answer choice. So that is the answer. And if you want to check, you can actually see that the numbers 41, 2, 5, 89, 3, and 67, they are all prime numbers, and they all use these numbers, right? And so this is actually a possible kind of combination that has a sum of 207. So that's the answer, it's B. Number 18, let C1 and C2 be circles defined by x minus 10 squared plus y squared equals 36 and x plus 15 squared plus y squared equals 81 respectively. What is the length of the chosen of the shortest line segment PQ that's tangent to C1 at P and to C2 at Q? So let's first draw a diagram here. Let's look at the total distance, and so that will be 25 in total. And what we can do is move this line to over here and move PQ to over here, right? Then what would that give us? Like this, right? So this length of PQ, that would just be transferred right here, and so we can see that this length is equal to PQ. And since this length is equal to this length, then this length is 9 and this length is 6, right? And so that would mean that we have this length, and that would be, this would be 6 plus 9, which is 15. Right, so this is 15, and so we have length 25 to 15, and this is a right angle, and so that gives us that it's a 3 to 4 to 5 triangle, right? Because that's a Pythagorean triple. So that means PQ, this is just 25 times 4 over 5, so this is 20, right? So PQ is 20, the answer is C. Number 19, the graph of the function f is shown below. How many solutions does the equation this have? Okay, so for f(x) to be equal to 6, then we need fx to be equal to, let's see, for fx to be equal to 6, then that means that would be just this line. Yeah, that would be this line over here, and that would get x equals 1 and negative 2, right? So fx, this would be 1 and negative 2. And if we have lines that show fx equals 1 and negative 2, then that would be fx equals 1, that would be this line, and negative 2, that would be this line, right? And so now if we look for the number of intersections, we have 1, 2, 3, 4, 5, and 6 intersections, right? So we have 6 values, and all of these are on different x points, right? So we have 6 different solutions. The answer is D. Number 20, suppose A and B are digits, not both 9 and not both 0, and the repeating decimal 0.AB repeating is expressed as a fraction in lowest terms. How many different denominators are possible? Okay, so since this one is since that's repeating, if we put that in fraction form, so 0.AB, this will be equal to AB, so that will be equal to AB over 99, right? And this is just, yeah, and this is just equal to like 10A plus B, right? And so but for this one, we want the number of denominators that are possible, right? So the denominators, they are factors of 99, right? And so the factors of 99, these will be 1, 3, 9, 11, 13, no, sorry, 33, and 99, right? But then the denominator, it cannot be 1, right? Because if it's 1, then that would mean that AB is 99. But then they can't be both 9, so 1 is not possible, and so therefore we have this much, which is 5 numbers. So 5 denominators are possible. The answer is 5. It's C. Number 21, consider the sequence of numbers 4, 7, 1, 8, 9, 7, 6 all the way, and for n is greater than 2, the nth term of the sequence is the units digit of the sum of the 2 previous terms. Let Sn denote the sum of the first n terms of this sequence. The smallest value of n for which Sn is greater than 10,000 is... Okay, so first of all, let's try to write out the sequence. Right here we can stop, because if we see up to here, this is so that much keeps on repeating, right? And so this is 12 numbers, so this is 12 numbers are repeating, and so their sum is 60 in total. Their sum is 60, right? And so using this, we want the sum to be approaching 10,000, right? So 10,000, this is 60 times, and then we have 166 plus 40, right? So this 166 means we have 166 sets of these 12 things, right? And we have to make the sum be 40. And so if we go from the beginning, then this is 11, and we have 12 until here. We have 20 until here. We have 29, and we have 36. 36 plus 6, this is 42. Yeah, so that's the first one where it exceeds 40. And so until here, that would be our nth term. And so we have 1, 2, 3, 4, 5, 6, 7 numbers, right? So we have 7 extra numbers. So the total number is 166 sets of 12 plus 7 more. So we will have 166 times 12 plus 7, right? And so that is equal to 1992 plus 7, which is 1999. So 1999 is the answer. It's B. Number 22. Triangle ABC is a right triangle with angle ACB as its right angle, and M angle ACB equals 60 degrees and AB equals 10. Let P be randomly chosen inside triangle ABC and extend BP to meet AC at D. What is the probability that BC is greater than 5 root 2? Okay, so let's bring up a right triangle here, like that. And so this would be A, this would be B, and this would be C, right? So ACB is the right angle, and this is 60 degrees, right? And since AB is 10, this is 10 degrees, and since this is 60, and this is 30, right? Then that means this is 5, and this is 5 root 3. AC is 5 root 3, right? And P has to be randomly chosen inside ABC, and BP to meet AC at D, and BD has to be greater than 5 root 2, right? But then for that, first of all, let's find the point where BD equals 5 root 2, right? If BD equals 5 root 2, that would be this point, right? So here, BD, this would be D, so it would be 5 root 2. Yeah, so that would be 5 root 2. And since this is a right angle, this would be length 5, right? So DC would be 5. And we want BD to be greater than 5 root 2. And so that means D should be inside this much, right? And so this much is AC minus DC, right? And so to get that probability, we have to do, it's all over 5 root 3, because 5 root 3 is all the possible length. And AD, that much is 5 root 3 minus this much, which is 5. Right, so that's 5. And so if we divide by 5, that gives us 3, that gives us root 3 minus 1 over root 3. So if we multiply the numerator and the denominator by root 3, that gives us 3 minus root 3 over 3. And so this is our answer. It's C. Number 23. In triangle ABC, side AC and the perpendicular bisector of BC meet in point D, and BD bisects angle ABC. If AD equals 9 and DC equals 7, what is the area of triangle ABD? Okay, so first we need to know what Heron's theorem is. Heron's theorem, right? Because we are going to use this to solve this problem, right? And this says that what if we have a triangle, if we have any triangle with the side length A, B, and C, then we can get the area of it if by setting that S is equal to A plus B plus C over 2. So if S is set as equal to A plus B plus C over 2, then the area is equal to square root of S times S minus A times S minus B times S minus C, right? So this is Heron's theorem. And like that's our formula that we are going to use when we are solving this problem, right? And so next let's just draw out what this problem is saying, and so let's make a diagram. So if we do that, this would be the diagram. And so here as it says, AC and the perpendicular bisector of BC, so this is the perpendicular bisector, they meet in point D, this is point D, and BD bisects ABC, so this and this angle are the same. So that means these two angles are the same, right? And if AD is 9, so this is 9, and DC is 7, right? What is the area of triangle ABD? Okay, so first of all, since this is the perpendicular bisector of BC, that means BDC, so that means BDC, that is an isosceles triangle, right? And so therefore, this angle would also be this red dot, and these two would be equal lengths, right? So BD has a length of 7, right? And also, since the sum of these two lengths are equal to this length, since the sum of these two angles are equal to this angle, then that angle becomes 2 of these, right? And so now if we look at triangle ABC and triangle ADB, they are similar, right? Because they have one angle of 2 dots and another angle of 1 dot, right? Also ADB has 2 dots and 1 dot angle, right? So that means ADB. Yeah, so that means ADB and ABC, they are similar, right? And so if we set AB length as x, right, then the ratio of AB to AD, that will equal AC to AB, right? And so if we put that in there, we get 9 over x equals x over 16. And so that gives us that 9 times 16 equals x squared. X is equal to 3 times 4, and 3 times 4, that is 12. So x equals 12. And since x equals 12, this is 12 here, right? And then we want the area of triangle ABD, and now we know all of its side lengths, right? And now we can use Heron's theorem. So since we know since we know the side length of triangle ABD, we can see its area. So first of all, our S would be equal to 12 plus 7 plus 9 over 2. This is 28 over 2, which is 14. So we get that S is 14. S equals 14, right? And so now we can use Heron's formula, Heron's theorem, whatever. This is equal to the root of 14 times 14 minus any one of these. 14 minus 12, which is 2. 14 minus 7, which is 7. 14 minus 9, which is 5. And so this gives us 14 times 14, so that's just 14 can go so that 14 can come out, so it's 14 root 5. So this is the area. That's the answer. The answer is D. Number 24, find the number of ordered pairs of real numbers a comma b such that a plus bi to the 2002nd power equals a minus bi. Okay, so first let's say that the magnitude of a plus bi, this will be s, right? And this is just equal to root a squared plus b squared, which is also equal to the magnitude of a minus bi, right? And so let's say that this is all equal to s. Then if we then the magnitude of this will be equal to the magnitude of that, right? And so that means the magnitude of a plus bi to the 2002nd power is equal to the magnitude of a minus bi. And so that means s to the 2002nd power is equal to s. So that means s equals 0 or 1, right? Because s has to be a real number. This is s, right? So s is a real number. And if s is 0, then we get a is 0 and b is 0, so we get just one pair. But if s is equal to 1, then the story gets different, because if it's 1, then we can have a plus bi to the 2002nd power, and this equals a minus bi, right? That's what it said in the problem. And now we can multiply. So we can multiply a minus bi to both sides. A plus bi to both sides, and so that will give us a minus bi, a plus bi, right? And so this will be equal to so that will be equal to a plus bi to the 2003rd power, and that will be equal to a squared plus b squared, right? And this is s squared, which is 1, right? And so a plus bi to the 2003rd power, that's just equal to 1. And so by this we can get a plus bi to the 2003rd power. This is 1. So we have 2003 pairs of a plus bi, of a and b, right? So we had 1 pair and we had 2003 pairs. So if we add them together, we get 2004 pairs. So the answer is E. Problem number 25. The non-zero coefficients of a polynomial p with real coefficients are all replaced by their mean to form a polynomial q. Which of the following could be a graph of y equals p of x and y equals q of x over the interval, this one, right? First thing that we need to notice is that the problem didn't give us the degree of the polynomial, right? So we don't know if it's a third degree polynomial or like a fourth degree polynomial or what, right? And so we need to focus on the fact that their coefficients, they are replaced by their mean, right? And so the mean, this means that the sum of the means is equal to the sum of the original values, right? Original values, right? And so this means that the sum of the coefficients are equal in px and qx, right? Px and qx, right? And that means that p1 should equal q1, right? Because if we put x equals 1 into a polynomial, then that always gives us the sum of the coefficients, right? And so we need to find a graph that shows us that p of 1 equals q of 1. So if we look at A, then no, they're different. B, oh yes, they are the same, so B is our answer. C, they are different. D, they are different. And E, they are also different, so B is our answer. The answer is B. Okay, so that was the last problem of the AMC 12A of the year 2002, and thank you for watching.